Hi everyone. In this lecture we are going to learn the basic concept prime number. Prime number, a number that can be divided exactly by 1 and itself, are nothing but prime number where the divisor should be 1 and the number itself. So in this video we are going to learn how to find the prime numbers and how to identify the prime numbers from 1 to 100. So let's start. Here I have considered the numbers from 1 to 100. Try to have the same representations of considering 1, 2, 3, 4 up to 5, 6 columns and the corresponding entries in the row. Let's start with the number 1, where number 1 is neither a prime number nor composite because it doesn't have the many factors, like only table 1 represents 1. So it's neither prime nor composite. Now let's move to more than 2 divisors, not a prime number. So let's consider an even numbers. So even numbers are 2, 4, 6, 8 and so on, and even numbers ends with the number 2, 4, 6, 8 and 0. The ending numbers of even numbers will be 2, 4, 6, 8 and 0. Let's start with the first even prime number, that is 2. It's an only even prime number. 2 whose divisors are 1 and itself. So 2 is a prime number. The same way you can check 4. 4 is an even number, but 4 has the divisors as 1, 4, 2. So it's not a prime number. So let's identify the column below the number 2. So you can see number 2. The digits ending with 2, 4, 6, 8 and 0 are an even number. So you can see the numbers here 8, 4, 0, 26, 32, 44, 50, 56. All these numbers are not prime numbers. In turn, we can say they are multiples of 2 are not here prime number. Let's consider number 4 now. As I said earlier, 4 is not a prime number, and below 4 you can see all the numbers are ending with 2, 4, 6, 8 and 0, and all these are not prime numbers. 2 is a prime number, but multiples of 2 is not a prime number. Let's go to 6, which is an even number. Again, it's not a prime number. So you can check the column below 6. All the numbers are ending with 2, 4, 6, 8 and 0. So these are multiples of 2, which has more than 2 factors other than 1 and itself. So they are not prime numbers. So most of the content in the table is finished. Let's start with number 3. Number 3 has the divisor 1 and itself. So 3 has a divisor 1 and itself. So it's a prime number. But multiples of 3 is not a prime number. So multiples of 3 you can identify in this column. See the column below the number 3. 3 is prime number. Below the number 3 you can check 9, 15, 21, 27, 33, 39, 45, 51, 57. When you add these numbers ones and tens place, the number will be divisible by 3. So all these multiples of 3 are not prime numbers. So you can strike it out. Now let's go for number 5. So 5 has a divisor 1 and itself. So it is a prime number. But multiples of 5 is not prime number. To identify that, take a diagonal from 5. Don't strike out 5. 5 is a prime number. So diagonal to 5 is 10, 15, 20, 25. Strike it out. The next number you can easily find out from the where you ended. Move to the corresponding last row, that is 30, 35, 40, 45, 50, 55. Same thing, we have ended at 55. Move to the corresponding last row. 60, 65, 70, 75, 80, 85. The same way move to the last row. 90, 95, 100. Multiples of 5 is not prime numbers. Now 1 is neither prime nor composite. 2 is prime, 3 is prime, 5 is prime. Let's go for 7. 7 whose divisors are 1 and itself. So it's a prime number. Now how to identify multiples of 7? Multiples of 7 is not a prime number. So we'll identify that. For this, below 7, take 7 count. So 1, 2, 3, 4, 5, 6, 7. That is 49. From 49, that is 49 will be a multiple of 7. Take the diagonal value. 49, 56, 63, 70, 77. Now to check the next number where we start at 49, proceed below that. 1, 2, 3, 4, 5, 6, 7, 91, 98. So the numbers which are left out from all this strikeout, those are the prime numbers from 1 to 100. Thank you.